Hello, everyone. Good morning, good afternoon, and good evening, depending on which part of the globe you are joining us from. Welcome to the next episode of AWS on Air, and we are in the second week of reInvent 2020. I'm sure you all are gaining some good insights into various new services, enjoying the deep dive breakout sessions, and having fun connecting with everyone across the globe. I'm Suman Devnath, a principal developer advocate from AWS, and I majorly focus on machine learning and data analytics. And I'm super excited to have Brian today with me, who is a senior product manager for Amazon AI. Hey, Brian, how are you doing?
Good. How are you, Simon?
Yeah, doing good. Thanks
Great.
for joining us.
Yeah, of course. Thanks for having me.
Sure. So last week we announced a bunch of new services. In fact, I guess we have announced five services which helps our industrial and manufacturing customers which are backed by machine learning. So today we are going to talk about one of those new launches, and that is Amazon Lookout for Equipment, which is an API-based machine learning service that detects abnormal equipment behavior so that industrial companies can avoid unplanned downtime and optimize performance. But before we go deep into this new service, let me ask you first, Brian, can you just brief our viewers and customers about this new service and share some insights about what type of problem it actually solves?
Sure. Yeah. So across a number of industrial applications, whether it's in oil and gas or power generation or manufacturing, a lot of companies have been measuring data coming from their machines, whether it's from sensors or process data from PLCs, and storing all of that data to try and get insights into how a machine actually operates. So Amazon Lookout for Equipment is an automated machine learning service that enables customers to bring that historical data that they've been measuring from this industrial equipment and automatically build models that learn the normal behavior types and relationships across all of the sensors that denote the normal behavior of a specific asset, whether it's a rotating equipment such as pumps or compressors, or other sort of assets that operate in some sort of process. And then whenever in real time, as we look for normal behavior, we'll be able to, say that the asset is operating normally, and any time that it's operating abnormally, we would unpack that and say, hey, right now we see an abnormal machine condition, and it's because of these reasons that we're seeing this as abnormal. So it enables predictive maintenance by giving customers the ability to model their equipment behavior and then get early detection of abnormal behavior that could be a precursor indicator of a failure.
Excellent. So I
Yeah.
guess this is very useful for the industrial and manufacturing units, because
Yeah.
there we don't have machine learning expertise, we don't have data scientists sitting there learning and going across the nuts and bolts of machine learning. So this is pretty easy for anyone to get started,
Hmm.
right? So it's amazing. So can you just tell us about a few of the new use cases that it enables, and how it can replace any of the current method that we have or anything that we had in the past?
Sure. So if we start off with some of the current methodologies used, again, this I'm going to speak broadly because there's a lot of different industrial applications out there. It's hard to sort of hone in on just one specific one. But the most common method that most companies use to monitor their equipment for health is single variable analysis, which is essentially looking at just like one variable over time, whether that's trending or if it's inside of an operating band. And that is useful information, but you're really leveraged to just that one variable and what information that can actually give you. So with that, companies start to move towards more physics-based modeling, where an engineer will sit down and write, okay, here's how I envision this machine actually operating. This sensor times that sensor should equal some value, and that should define the behavior of this specific machine.
Right.
However, yeah, so now as you start to expand out the scope where you have, let's say a couple hundred sensors on a specific compressor or pump or anything, the complexity starts to grow. So if you start to have a lot of single variable analysis, you're going to get a lot of alarms. If you start to model out physics-based models, it's time consuming and requires a lot of expertise. So with Amazon Lookout for Equipment, we've built a way to directly build an ML approach that will learn the normal behavior from the historical body of information that you have. So you no longer have to deal with all of the alarms from hundreds of sensors. Instead, we're learning relationships across all of the sensors that could impact or be insightful into how the machine's actually performing.
Absolutely. So it's incredible that how this service is catering
Yeah.
across a wide range of industries, and because when we talk about sensor data, it's a lot of data that gets pushed in to the data center or
Yep.
to the cloud. So it's great. So speaking of this, can you share a bit about how one can get started with it, and let's say who's new to this and how to get started?
Sure. Yeah. I also think that I missed a question of yours on example use cases, but we can get back to that in a second. Getting started on this, if you go to just aws.amazon.com, right now we're in a private preview, which you can then go sign up for. Go sign up, and we'll start allowing customers access to the service. And just read through some of the documentation and make sure that you're a valid application and use case. And just the sign up list, but from aws.amazon.com, look out for equipment, and we'll get you signed up.
Okay,
Yeah.
great. That's
Yeah.
pretty simple and
Yeah. Pretty.
straightforward.
Yeah. Yeah. We need some historical body of data. We're assuming that there's at least somewhat of like 6 months of historical data on a specific asset that's causing you a lot of downtime. We also request historical labels of failure times. So if you have times in which your assets have failed in the past, we'll use that information to help us better define the normal behavior of your machines. So, if you go on Amazon, AWS at Amazon.com, you have a historical body of data from a machine that's, been causing you some problems, and you have the maintenance logs. We can show you exactly how to use that information to model your machine better.
Excellent. So
Yeah.
you mentioned about the data that is needed, and for any machine learning, it's a general principle that the more the data is, the better the model will predict.
Yep.
So, but speaking of that, does it do supervised machine learning?
So, yeah, that's a great question. And one of the common things that we see across the industrial space is the expectation of, I'll put a quote unquote predictive maintenance, where, when you hear predictive maintenance, you expect that there would be, I'm going to tell you 30 days from now, your asset's going to fail with 80% probability. Um, that is not uh, normally very. It's not easy to do in this space because a lot of industrial equipment operates in a very unique pattern. So even the same pump or compressor next to each other, the two pumps would probably operate somewhat differently. So doing supervised machine learning is not necessarily going to work all the time. And even if it does, it might not be as scalable as one might originally think. So we do not do supervised machine learning here. We utilize unsupervised techniques to try and define the operating states of a machine in order to better detect abnormal conditions. So we're not doing any supervised machine learning here.
Great, got
Yeah.
it. Yeah. So, one other thing when it comes to this particular new service
Mhm.
is the type of sensors. So, what type of sensors does the Amazon Lookout for Equipment works with, and can we do any real-time analytics with that?
Yeah, good question. So, we work across a number of sensors. What we're trusting is that our customers have done the analysis to figure out what sensors they think they need to monitor the critical behavior or the critical components of their equipment. That includes vibration, temperature, RPMs, flow rates. There could be valve positions. Like there's a bunch of information that's being measured across a number of different assets. We'll use all of that. We're assuming that you're measuring this data for the purpose of it because it's valuable. And so as long as it's a time series data, a time series set of data generating from your equipment, what we're going to do is we're going to look for patterns across all of those sensors um, that denote the normal behavior. Now, if you're not measuring critical information, let's say you're missing some critical vibration information, I can't necessarily guarantee that we can detect issues as I would if you had all of the critical measurements that you need. I missed the second question in there. What was the second question?
Yeah. So the
Yeah,
following question was, can we use this for real-time analytics, like real-time
yeah.
inference?
So yes, so we've built this to mostly be a real-time monitoring solution, right? So the way that it works is that you bring your data, you bring your historical data, and we form a model of what the normal behavior would look like, and we walk the product walks you through the process to do that. And then once you've built your model and you're happy with the model that's been built, just in very simply sending data to S3, we'll run data through that model and output the results back into S3. So for companies that already have either data in the cloud or even data in on-premise systems such as Pi historians, we move that data to S3, build a model, and we can set up for real-time equipment monitoring. And the output from the real-time analysis can then be leveraged into any visualization or UI tool that already exists to be able to give actionable insights to the people in the field.
Awesome. So I
Yeah.
think this is, pretty amazing that, how, we are, doing all the heavy lifting and letting our customer, make use of this particular service,
Hmm.
at an API level, right? So, so we understand that this is an API-based ML service, just like any other service, like recognition or comprehend that we use or any developer use. But when we talk about, Amazon Lookout for equipment, does it use any pre-trained model? Because for various industries, as you just mentioned, oil and gas or turbine, etc., there are different operating environment and there are
Yeah.
different types of sensors. So does it use any pre-trained model, or if not, then how it actually works?
So no, we do not use any pre-trained models. I would love to be able to do that, but the reality of the industrial world is that even the same asset with the same sensors on it in the same location will operate differently. So what we do is we build custom models for each individual asset. But as a product, we try and make it as easy as possible for someone to accomplish the complexity of the data science without needing to understand any of it, right? So you can bring your historical data from this asset, and we will build a custom model that learns the normal behavior of your asset based on the conditions in which it's been operating in. And it builds that custom model that then can be leveraged via an API. Yeah,
Awesome. Great. So, I mean, that would surely make the model more, more robust and more customized rather than
yeah,
making a pre-trained model for all the problems. Yeah.
yeah.
So, so tell us a little bit about any of our existing customers or the users who are already having their existing systems. Do they need to replace anything, or it can seamlessly just get integrated with this particular service?
Yeah, so we're making it so it can be seamlessly integrated with this particular service, right? Some of our customers have, a lot of our customers have on-premise databases that they want to continue to leverage. They also have existing visualization softwares or HMIs that they use for their field teams. We've built this to just mostly be an analytics backend to the systems that they already use. So if a customer already has an on-premise system, they could move the data that they want to model into an S3 bucket in the cloud. We will build our model, and the model will still exist in the cloud. But then, as new data is generated from their sensors, placed into their on-premise historians, those historians can push it to S3. We'll run our model, get the analytics, and we can push it back to the historian. So we're meant to be leveraged by the existing, like a plug-in into existing systems without needing to be replace any of the things that you already have.
Okay, great,
Yeah.
got it. So you talked about a couple of times that we need to have the data in S3. So is it very much exclusive to S3, or it can leverage any live stream a data source as it's a data source?
So it's exclusive to S3. The reason for that is because what we've seen so far is that companies that have some sort of like on-premise historians or even their data in the cloud will the way that we run our inferencing or get the results in real time is almost like micro batching. So we'll send like a small snippet of data to S3. We'll run that data through the model and get the output at frequencies that right now up to 5 minutes. So if you have sensors taking readings every second, let's say for 5 minutes, that batch of 5 minutes of data will show up in S3. We'll run that through the model and output the results. So it seems to coincide with how a lot of the operations work in the industrial space, where getting the low latency is not as much required as getting the results in that sort of like micro batched framework.
Right. Yeah, it makes sense.
Yeah.
And I guess for any machine learning that we do anyway on AWS, we always prefer to have S3 as our data source because of obvious reasons. So that's perfect.
Yeah.
So one question that also hits me is how do you determine that which condition are normal when we talk about predicting abnormality on any of the equipments? How it actually determines that this is normal for a certain application, because for different applications a few things might be certain, and for the same state might be abnormal for some other applications. So,
Yeah, that's a really good question. So the way that Amazon Lookout for equipment works is that we'll take in your historical time series data. Let's say it's like a year's worth of historical data. And the companies that we've worked with so far also have maintenance logs. So they have logs at times in which they've made fixes or they've noticed some sort of issue in their equipment. And we consume that information as a time interval. So this time interval, as you know, when a machine failed, and let's say a day, 2 days, 3 days, 4 days, a week, a month earlier, is a time at which we would expect there to be abnormal conditions. So when a company has maintenance logs, we'll take in that maintenance information as a bunch of time intervals, and those are times at which we know the equipment to be abnormal, or we would expect the equipment to be abnormal if that specific failure or issue is detectable. We use the remaining time to define the behavior as normal.
right,
Yeah,
right. So that makes a perfect sense, because there are
yeah.
different applications and there are different threshold, and that every
Yeah.
application has its own different need. Right. So, one other thing is, when we talk about machine learning and when we talk about so much of data coming in, and sensor data has a very high, frequency of ingestion, right? So we get
Mhm.
data every minute or even every second. So I guess we have some sampling as well. That even if my data is having a frequency of, let's say, every 1 minute, but while we train this model, it can we can specify, don't take every minute samples. We can just do the down sampling, right?
Yeah, so that's a really good question. We do downsampling in the product, right? Because um, companies have wide varieties of different amount of sampling rates per sensor, and even if you talk about like getting high frequency data either from something like current or vibration, that data needs to be like the feature engineered first to get the critical information out of the current or vibration data first. And then inside of the product, we will give the ability to downsample. So instead of having data coming up every second, that might be too frequent. You can just sub-select every 15 seconds, 30 seconds, 1 minute, and we'll downsample the data to make sure that we can reduce a lot of the training time, and a lot of oftentimes like that high frequency sample rate is not really necessary for some of the equipment that we monitor.
Right. Yes.
Yeah,
I think that's overwhelming of data. It may not be needed, so it makes perfect
yeah.
sense to downsample, right? Yeah. So one last thing is, when we talk about this service, from the modeling standpoint, does it take just one sensor data, or it just aggregates a number of sensors data together to have an understanding of the baseline?
I'm not sure I understand the question. Are you asking if we do like single variable analysis or multivariable? Is that?
Yeah, so basically,
Yeah.
does it use this one sensor data, or it just aggregates the data from coming from various sensors?
Yeah, so we aggregate the data coming from various sensors for sure. in a specific asset, like let's say just take a pump as an example, might have 20 or 30 sensors on it at the high end. We'll take all of that information together and we learn the relationships across all of the sensors. So just like for the pump example, something like um, how fast the pump is spinning has a relationship to how fast the fluid is being pumped out of, right? So that relationship to each other is the critical information that we're trying to derive that defines normal. So we'll take all of the sensor data and we'll find the cross relationships across all of those sensors to try and define that normal behavior, not just one sensor alone.
Right.
Yeah.
Yeah. So the more the lastly the one of the thing that always any customer would always ask is about the pricing. So how is that pricing model?
Yeah, so it's obviously public, so you can go and check it out as well. But we have three major APIs that have charges affiliated with them. The first is an ingestion step, so it's just a charge per gigabyte to bring your historical data, and then we have a model training charge, so the amount of compute resources in order to train the initial model. And then for inferencing, we've built a scheduler. So at our scheduled rate, a customer wants to set up inferencing, let's say every minute, 5 minutes, 10 minutes, 15 minutes. Um, you can just set that rate and say, okay, every 5 minutes I want my inference results. And so we've built this scheduler, and we have a charge per hour, regardless of the amount of the scheduled rate that you choose. The data will be the same. The amount of data is the same, like if you want it at 1 minute or every 60 minutes. But we just, you can schedule it to whatever your requirements are.
Excellent. So
Yeah.
I guess one of the major challenge with many of the industrial and manufacturing companies that which they face today is the ongoing maintenance of their equipment. And historically, those maintenance can be either reactive or preventive in nature. But now I'm very sure that this is going to change the game for our industrial and manufacturing our customers in a big way, because this service enables our customer to do predict maintenance, as you rightly mentioned,
Yeah.
using machine learning without the need of understanding the nuts and bolts of machine learning, right? So that's an amazing service that we have launched in this reInvent. So thank you so much, Brian, for all your time joining us here at AWS on air and sharing insights about this new service. And I would strongly recommend all of our users and customers to go and check this out and sign up for the preview. Thank you so much for your time, Brian.
Yeah. Thank you. Appreciate it. All right.
All right. So thank you so much, everyone, for joining us. I'll see you in an hour from now, where we will be discussing about one more new launch. And that time it would be on analytics. Until then, stay tuned, enjoy the reInvent, and keep building awesome products. Bye bye.